Mastering design optimization techniques. Optimization ignites excellence by slashing waste and amplifying value. Why do the key principles of design optimization, which encompass the integration of design parameters, manufacturing constraints, and performance metrics, play a crucial role in facilitating operational excellence by minimizing waste, reducing variability, and maximizing value in an organization's products, services, and processes? The key principles of design optimization play a crucial role in facilitating operational excellence by minimizing waste, reducing variability, and maximizing value in an organization's products, services, and processes. Design optimization is a systematic approach that integrates design parameters, manufacturing constraints, and performance metrics to create optimal solutions that meet customer requirements while minimizing costs and maximizing efficiency. The integration of design parameters is essential in design optimization as it enables the identification of critical design elements that impact the performance of a product or process. By analyzing these parameters, designers can create models that simulate real-world scenarios, allowing them to test and validate different design options. This leads to the creation of optimal designs that meet customer requirements while minimizing waste and reducing variability. Manufacturing constraints are another critical component of design optimization. These constraints include factors such as production capacity, material availability, and equipment limitations. By considering these constraints, designers can create designs that are feasible to manufacture, reducing the risk of production delays and errors. This, in turn, leads to a reduction in waste and variability, as well as an increase in value. Performance metrics are also essential in design optimization, as they provide a way to measure the effectiveness of different design options. These metrics can include factors such as product performance, reliability, and maintainability. By using performance metrics, designers can compare different design options and select the one that best meets customer requirements while minimizing waste and variability. The integration of design parameters, manufacturing constraints, and performance metrics enables designers to identify optimal solutions that maximize value while minimizing waste and variability. This is achieved through the use of design optimization techniques such as parametric modeling, simulation, and sensitivity analysis. These techniques allow designers to explore different design options, test and validate them, and select the optimal solution. One of the key benefits of design optimization is its ability to minimize waste. Waste can take many forms, including material waste, time waste, and energy waste. By creating optimal designs that meet customer requirements while minimizing waste, organizations can reduce their environmental impact, decrease costs, and increase customer satisfaction. Design optimization also reduces variability by creating consistent and reliable products and processes. Variability can lead to defects, rework, and customer dissatisfaction. By minimizing variability, organizations can increase product quality, reduce warranty claims, and improve customer loyalty. In addition to minimizing waste and reducing variability, design optimization also maximizes value. Value can be measured in terms of customer satisfaction, revenue growth, and market share. By creating products and services that meet customer requirements while minimizing waste and variability, organizations can increase customer satisfaction, drive revenue growth, and gain a competitive advantage. Furthermore, design optimization facilitates operational excellence by enabling organizations to respond quickly to changing customer requirements and market conditions. By using design optimization techniques, organizations can rapidly create and test new design options, allowing them to stay ahead of the competition and respond to changing market conditions. Design optimization also enables organizations to create a culture of continuous improvement. By using design optimization techniques, organizations can identify areas for improvement and make data-driven decisions to optimize their products, services, and processes. This leads to a culture of continuous improvement, where employees are empowered to identify opportunities for improvement and make changes to optimize performance. In conclusion, The key principles of design optimization play a crucial role in facilitating operational excellence by minimizing waste, reducing variability, and maximizing value in an organization's products, services, and processes. By integrating design parameters, manufacturing constraints, and performance metrics, designers can create optimal solutions that meet customer requirements while minimizing waste and variability. The benefits of design optimization include reduced waste, reduced variability, maximized value, rapid response to changing customer requirements and market conditions, and a culture of continuous improvement. By adopting design optimization techniques, organizations can achieve operational excellence and stay ahead of the competition. The pursuit of perfection: how design optimization techniques can unleash operational excellence. I recall a particularly grueling project I worked on with a leading automaker. They were struggling to optimize their design process, and it was taking a toll on their bottom line. They had a fantastic product, but the production line was plagued by inefficiencies, resulting in wasted resources, delays, and compromised quality. As I delved deeper into the issue, I realized that the root of the problem lay in the design phase. The company was focusing on individual components, rather than taking a holistic approach to design optimization. They were trying to solve isolated problems, instead of tackling the entire system. My first instinct was to gather data on every variable that could affect the design process. I mean, everything, from material properties to manufacturing constraints. It was a daunting task, but necessary to create a comprehensive understanding of the system. I remember thinking to myself, this is like trying to drink from a fire hose. But we persisted, and the data started to reveal some fascinating insights. We discovered that by integrating design parameters, manufacturing constraints, and performance metrics, we could identify areas of inefficiency and eliminate them. It was like finding the Achilles heel of the production line. By optimizing the design, we could reduce waste, variability, and maximize value. The potential savings were staggering. One of the most significant breakthroughs came when we applied the principles of design optimization to the supply chain. By analyzing the entire ecosystem, we found opportunities to streamline logistics, reduce inventory, and improve delivery times. It was remarkable to see how these changes rippled throughout the organization, freeing up resources and energy to focus on innovation and growth. As I worked with the team to implement these changes, I couldn't help but feel a sense of pride and accomplishment. We were not just optimizing design parameters, we were transforming the very fabric of the organization. The culture was shifting from a focus on individual components to a holistic approach that prioritized efficiency, effectiveness, and excellence. The results were nothing short of remarkable. Production times decreased, quality improved, and costs plummeted. But what struck me most was the impact on the people involved. The team was more engaged, motivated, and empowered to drive change. They had a sense of ownership and pride in their work, knowing that every decision, every optimization, was contributing to the greater good. As I look back on that project, I'm reminded that design optimization is not just about technical wizardry or data analysis, it's about creating a culture of excellence. It's about recognizing that every aspect of the organization is interconnected, and that even the smallest improvement can have a profound impact. In the end, our pursuit of perfection did not yield perfection, but it did yield something far more valuable: a culture that embraced continuous improvement, a culture that celebrated the beauty of optimization, and a culture that recognized that true excellence is a never-ending journey, not a destination.